Let's do section 11.1, exploration 1, which reads, consider the cycloids with parametric equations, x equal to a times t minus sine t, y equals a times 1 minus cosine t, and a is going to be greater than 0. So part 1 reads, graph the equations for a is equal to 1, 2, and 3. Now I chose to graph these for the interval of t from 0 to 4 pi, and my axes went out to 20 in x and about 10 in y. And when I graphed a equal to 1, I got something like this. When I graphed a equal to 2, I get something like this. And when I graph a equal to 3, I get something like this. So I get all of these different arches. Part 2 asks us to find the x-intercepts, and that means that y is going to be equal to 0. So our equation for y is y equals a times 1 minus cosine t, and I'm going to set that equal to 0. So I've got 0 is equal to a times 1 minus cosine t. I can divide both sides by a because I know that a has to be greater than 0. So I'm going to end up with 0 is equal to 1 minus cosine t, or cosine t is going to be equal to 1. Now this is going to happen for values of t like 0 and 2 pi and 4 pi, etc. And we can abbreviate this as 2n times pi, where n is going to be any integer. So I'm interested in what the x values are actually going to be, so I'm going to substitute this value of t back into my equation for x. So I've got x is equal to a times t minus sine t. So x is going to be a times 2n pi minus the sine of 2n pi. And we know that any multiple of pi, when we take the sine of it, we're going to get 0. So I'm going to end up with x is equal to 2an pi, and those are going to be the values of my x-intercepts. For part 3, we're supposed to show that y is greater than or equal to 0 for all t. So y is equal to a times 1 minus cosine t. And let's remember that for all t, negative 1 is going to be less than or equal to the cosine of t. It's going to be less than or equal to 1. So let's look at the extremes here. When cosine t is going to be equal to negative 1, y is going to be a times 1 minus negative 1, which is going to give us 2a. And when cosine t is equal to positive 1, y is going to be a times 1 minus 1, or 0. So really, y is going to be bounded by 0 and 2a. And because a is greater than 0, that's going to tell us that y is going to be greater than or equal to 0. Part 4 asks us to explain why the arches of a cycloid are congruent. And basically, they're congruent because each arch is produced by one complete turn of the wheel. Part 5 asks us, what is the maximum value of y and where is it attained? Now, as we saw in Part 3, we know that the maximum value for y is going to be at 2a. And this occurred when the cosine of t was equal to negative 1. And if we want the cosine of t to be equal to negative 1, that means that t needs to be an odd multiple of pi. So 2n plus 1 times pi. And of course, if we're asked where it is attained, we are looking for the x values. So remember that x is equal to a times t minus sine t, and now we're just going to substitute in this value of t. So x is going to be a times 2n plus 1 times pi minus the sine of 2n plus 1 times pi. And we know that any integer multiple of pi is going to give us 0 when we take the sine of it. So we're going to end up with x is equal to a times 2n plus 1 pi, and that is where those maximum values are going to occur. And finally, in part 6, we're asked to describe the graph of a cycloid. And of course, you could have a lot of different answers for this, but you should probably talk about how it is periodic with a period of 2a pi. You should probably say that each arch represents one period. And then, of course, we can talk about the individual arches here and talk about how each arch is going to be concave down, that it has an absolute maximum of 2a at the midpoint, and then there are absolute minimums at both of the endpoints.